In the previous video, we have created an Spring Authorization Server and we did a few configurations such as storing users and client information in the database, as well as storing the authorization and consent information in the database as well. Also, we were storing user session in the Redis database. In this video, we will add one more authentication mechanism to Spring Authorization Server, which is authentication using WebAuthn. So in this video, first we will go through basics of WebAuthn and Passkeys and how they work. And after that, we will jump over to code. So WebAuthn is a standardized protocol, and this is a W3C published. So I will put some links at the end of this slide. You can look at those. So this provides some API definitions as well for websites to authenticate using passkey and establish guidelines for authenticator functionality. So basically, we will see different roles involved in WebAuthn. So it provides uh, the data format which needs to be interchanged between different roles, and it utilizes digital signatures to verify user identity. So it accomplishes that using this cryptography. So it uses asymmetric cryptography so that private key can be used to sign something and public key can be used to verify that signature. So the use case are user registration, identity verification, that means authentication, and this can be used as multi-factor authentication as well. For example, uh, as a first factor, you may allow users to log in using username and password, and you can use this WebAuthn as second factor authentication. And so, in order to store the key, that means the private key, it relies on the authenticator itself. So the key is stored in the authenticator, which we will see what that is, and not at the server in most of the cases. So that was WebAuthn. Now let's see what is passkey, because many of the times WebAuthn and passkeys are used uh, like with each other, and sometimes they are used interchangeably as well, but they are not the same thing. So WebAuthn is this whole infrastructure or this protocol or this framework, whatever you call it. And what is the passkey? Passkey is this credential. So if you see here, this key storage. So whatever is stored in the authenticator as credential, so that is called passkey. Yeah, so this is a non-technical term for WebAuthn credential. So there can be multiple forms of WebAuthn credential, and one is called passkey. So this is a public-private key pair associated with a specific user account on a specific website. So your authenticator can store following thing: RPID. RP is relying party ID, and user handle, which can be the username in that website. Then it stores the username. Then it stores the credential ID, which can be some unique key. Then it stores the private key, using which it can sign the data, and the public key can be used to verify that signature. Yeah. Now let's see what is WebAuthn Authenticator. So this is responsible for generating and storing the WebAuthn credential, that means passkey. So there are different types of authenticators. First is platform authenticator. So some platforms have built-in support of this authenticator. So for example, Apple Keychain, Windows Hello, and Android. So you don't need any additional device for platform authenticators, but you can use additional devices as well if you need. And those additional devices are called roaming authenticators. So for example, in some platforms, the support may not be there. For example, I'm using Ubuntu and I think this does not have this support. So you can use like smartphones, or you can use some physical security key as well, which is called UB key mostly. So you can use that as roaming authenticator. So roaming means you can keep that device with you, and wherever you need to log in, which does not support platform authenticator, you can use, for example, USB or Bluetooth or NFC to connect both devices, and then your roaming device or roaming authenticator can be used on any platform. And also some password managers can also be used as authenticator. And some of the authenticators support this cloud sync. So for example, if you have multiple Android smartphones with the same account, then they both sync your private key and these things. And if you have multiple Apple devices, then they also sync their keychain data with each other. Now, why do we need WebAuthn? So the first reason is secure credential generation and storage. So in a typical or in a normal scenario where you use username and password to authenticate the user, then the password is stored at your database. So this has many drawbacks. For example, weak passwords can be easily brute forced, and you can read all these, but basically WebAuthn eliminates this completely. So you don't store anything on the server, you just store the public key, and public key is meant to be shared to the public. So even if someone gets hold of the public key, uh, they cannot do any harm to your server or the user's account. The credential is stored in the user's authenticator. So all of these drawbacks of uh, like normal username password authentications are eliminated. Then yeah, we have seen like no server-side credential storage. So if you don't have any passwords to store in your server, then you don't need to worry about hashing of the password or protecting your database and these kind of things. You don't need your users to alert for periodic password changes, these things. And also you can prevent your users to be a victim of phishing attack, because even if some other website looks completely similar to your website, uh, but since the uh, host name will be different, so they won't be able to steal the credential from the authenticator, which is meant to be for your to be used for your website, since it creates unique credentials for each website. So those were the reasons. Now these are the components of WebAuthn. First, we have relying party (RP), which is the basically website or server where user needs to be authenticated. Then we have WebAuthn client, which is generally a browser where user will enter their details to authenticate. Then we have WebAuthn authenticator. So this is where the WebAuthn credentials are stored. So in the WebAuthn, we have two flows: registration flow and authentication flow. So authentication flow is called verification flow as well most of the time. So in the registration flow, the user registers a credential to a relying party. So in the authenticator will generate a public private key pair given for the given relying party username and like the website host name, these things. And in the authentication flow, it will uh, it will sign some data using its private key, and server will verify using its public key. So let's let's look at this one image. So here, so this is authentication flow. Uh, so authentication and verification flow both are uh, like similar. There are some minor differences which we will see. So here, whenever user needs to authenticate, what is happening is the client will ask the server for some challenge, and it will pass that challenge to the authenticator. The authenticator will sign the challenge. It is called assertion as well, signed assertion. So authenticator will first verify the user using fingerprint, face, or PIN, or whatever mechanism is there. Then it will sign the assertion. Then the client will send the signed assertion to the server. Server already has the public key for this credential. Then it can verify using the public key whether the signature is correct or not. If yes, then the authentication is successful. Otherwise, it is rejected. Now let's look at the registration flow. So these are the steps. First, client sends the registration request to the relying party server. Then relying party server replies back with registration options. And in the registration options, we have these things mostly. So random challenge, which will be used by the authenticator to sign. So, so authenticator will sign this challenge, and the RP ID. So relying party ID. It usually is a domain, but it can be different as well. And then it provides a user ID as well, for which the credential needs to be created. It provides some supported cryptographic algorithms and authenticator preferences, uh, which we'll see later. And I will provide link where you can read more about these preferences. So after that, client, that means the browser, will invoke the WebAuthn API. So WebAuthn API, nowadays most of the browsers support WebAuthn API. So they will call this navigator.credentials.create method, and they will provide a few options. For they will provide public key, and so this is the challenge which is received from the server. Then the details of the relying party like ID and name, the details of the user, ID of the user, then name of the user, display name, these things, and then public key credentials. So this will be like supported algorithms, and so you can see most of the data is in the form of integer arrays, so like byte array. Then authenticator does all these things, verifies the user, then it generates a key pair. Since this is a registration flow, so the credential is not present in the authenticator yet. So authenticator will generate a key pair, and it will return an attestation, um, um, which has a type public key credential. So public key credential, this is a type defined in this WebAuthn API. You can read more about that there. I will provide the link. And then the browser sends the attestation to the RP server. Now, in this step 5, we have this attestation. So let's see what this attestation contains. So once the authenticator verifies, generates private public key, and signs that challenge, then it will return with this information. So browser will have this information, or client will have this information. So first of all, it will be ID. This is a credential ID. Then row ID. So this basically ID is base64 URL encoding of row ID. Then type is public key, since we specified public key here. And for passkeys, it is always public key. Then authenticator attachment, whether it is cross-platform or platform. And so cross-platform basically means roaming authenticator. Platform means the platform authenticator. So which type of authenticator was used? Okay, so like you can even specify here. So for example, here the resident key user verification. So in the authenticator preference, you can even ask like uh, if you only want to use platform authenticator, so you can ask that. If you only want roaming authenticator, then you can ask that. And then it will have the response. In the response, it will have attestation object. And so this will be the array buffer containing authenticator data and an attestation statement for a new key pair generated by the authenticator. Then it will have the client data JSON. So this is the serialization of the data passed from the browser. So whatever browser passed to the authenticator for this registration flow, the same data will be present here in the uh, JSON format. Okay, once the server receives this information, it verifies the information. It verifies whether the challenge is uh, same or not, whether the origin is correct or not. So server can specify the allowed origins, whether this RPID message or not, signature is valid or not, and yeah, it can even verify this user presence or user verification requirements, whether the authenticator actually verified the user or not, and then it can check this attestation as well. And then server will store this information: user ID, credential ID, public key, signature counter. Signature counter is basically how many times that credential has been used for um, to sign the challenge. Okay. Some authenticators may provide this, some may not provide this. For example, most of the roaming authenticators provide, I guess, 0 uh, for its value. So this depends on the authenticator, and this is used or this may be used by the server uh, to, to track whether the authenticator has been compromised or not. Okay, so that was the registration flow. Once the server stores all this information, mm, now in the authentication, server will use all this information. So now client will send a login request to the server. Now server does not know which user is trying to log in. Then it will return back with the challenge, RPID, and list of allowed credentials if username is known. But if username is not known, then there won't be list of allowed credentials. So only the challenge and RPID. Then again, browser will ask the authenticator to sign the challenge. Now this time the API will be navigator.credential.get, and the public key, in the public key option we will have the challenge, we will have the RPID. Now in this case we don't have the full RP information because we don't need it. We just need RPID. Then uh, allow credentials and so allow credentials if we already know the username. In that case, it can server can return with this allow credentials, and user verification, whether user verification is required or not. User verification means like fingerprint of the user or pin. These things are required or not in the before signing the challenge by the authenticator. So if authenticator contains one of the given credentials, so if allow credential is not empty for the given RPID, then it asks the user to select one if multiple matches are found. Then it will sign the challenge and it will ask the user for consent. Okay. So, but if allow credential is not empty, then it will try to find by the RPID. Okay, so whether there is some credential, is if there is any credential present for the given RPID. If there are many, then it will ask which one to choose, and then it will return public key credential. So in the next page, we will see. Then client will send the credential to the RP server, and then the server will verify the signature and other data, similar to what it did for the registration flow. And this is the data which the authenticator will provide to the browser. So row ID and ID, this is the ID of the credential. Then type, it will type will always public key. Then authenticator attachment, whether it is cross platform or platform, and then the response. In the response, it will have the authenticator data, which will be the array buffer containing information from the authenticator, such as the relying party ID has signature counter, test of user presence, and user verification flags. Um, so, so basically the information about what happened at the authenticator. Then client data JSON. So this is what the browser sent to the authenticator. And then there will be the signature of the challenge, and then some user information. For example, user name, their display name, and these things. So basically, there are two types of credentials: discoverable and non-discoverable. So discoverable credentials are called resident keys as well. Non-discoverable are called non-resident keys. Why? Because discoverable for the discoverable clients, most information is stored in the authenticator, but for non-discoverable, it is stored in the server. And let's see how. So whenever you call this create API of this WebAuthn, then in the authenticator selection, you can specify require resident key. It can be true or it can be false. So if it is true, by default it is true. Uh, that means the credentials, public key, private key, these things will be stored in the authenticator itself. But this required resident key is deprecated, and now you can use resident key. Its value can be discouraged, preferred, or required. Default is preferred, I guess. So discouraged means don't use resident key, use non-resident keys. Preferred means try to use the resident key. Required means it is compulsory to use resident keys. So non-discoverable credentials. So we have seen discoverable credentials. So whatever we have seen previously was discoverable credentials, because the private key and the credentials were stored in the authenticator. But for non-discoverable credentials, this information is stored at the RP server, like username, ID of the RP, encrypted private key and public key. Now, the important thing is the private key is encrypted when it is stored in the server. So even if someone is able to install the encrypted private key or public key, they can't do any harm, because uh, in order to decrypt the private key, the master key is stored in the authenticator. So what will be the flow in this case? We want to go over the whole flow because only a few things are changed. So in the registration step, the authenticator will generate the key pair. It will encrypt the private key and other data with the master key. And it will return the encrypted private key along with other data to the relying party. Now the RE server can store the encrypted private key, public key, other information. So in case of authentication, what happens is that the relying party will pass the credential ID into the credentials container.get call. So this is also WebAuthn API. And in this case, it will provide the credential ID, the encrypted private key along with other data. Then so here this is wrong. This will be decrypt. So the authenticator will decrypt the encrypted private key using the master key. Then it will have the private key, and then using that private key, it will sign the challenge. And then the authenticator will use, yeah, so authenticator will use the private key, and then the RP server can verify the challenge using the public key. Okay, so the advantage of non-discoverable is that authenticator does not have to store any credential specific data. It just need to store a master key, and the same master key can be used across multiple uh, relying parties. So theoretically, it could support an infinite number of credentials. The disadvantage is the user the user needs to supply their username whenever they want to sign in using WebAuthn, because the RP server needs to provide the encrypted private key as well in the authentication flow, and without user ID, it can't provide. And this cannot be discovered as well. For example, whenever you are trying to log in using web authentication, then you see a list of credentials. But since in this case you don't have any credentials stored, you just have one master key. So your authenticator cannot help you uh, with that. It's only the relying party server which can ask or which can provide the username for which you need to sign in. So authenticator cannot help you selecting any user or anything. It cannot be discovered basically. Now, so this is the discoverable credentials. So in the discoverable credentials, the authenticator itself store the private key, username, ID of the relying party, and these things. The advantage is that the browser can discover the credentials associated with the RP. So it can display the usernames and you can choose which username you want to log in as. And passkeys are always discoverable credentials. These are the references. You can look at these. Okay, now let's write some code. So I've already created this project. So we will use the project which we created in the last video itself. Okay, and this is the project. So let me go to authentication config. In the authentication config, we have this form login, auth to login, and one-time token login. So I made one improvement. So earlier, for one-time token login, we did not do any customization like where to store the tokens. So by default, tokens are stored in the memory. But now I have created a bean here to store one-time tokens in uh, database using JDBC one-time token service. And for it to work, we need to have one schema, which is this one. One-time tokens table is needed with these three fields: token value, username, and expired set. So I just created this one, and this is working basically. Now, before doing any customization, let's look at the default implementation of WebAuthn in the Spring Security. So Spring Security provides that to us. So I will just comment out these. I will say form login with defaults, and then we can say WebAuthn. Now for this one, we need one dependency which provides the implementations. So let's go here. Yeah, this is the dependency. And you can look at this reference. So I will provide all these references. So this dependency is needed. Spring Security WebAuthn. So we need to provide a few things. Let me do this. WebAuthn dot RPID. So this is the relying party ID. Let's just say localhost, then name, and let's say demo. Then we can say allowed origins, uh, so that it will only allow the request from these origins for authentication and registration. Let me do localhost. I'm just hard coding these here, but you obviously should not put this in some environment variable or somewhere. Do we need anything else? No, I think this should be enough. Okay. So we have this one here. So I am not enabling like rest of these. Let me first start the Let me start the database and these things. So Docker compose up. Okay, so this has been started, and yeah, along with this, let me show you one something else. So we want to store the data related to WebAuthn as well in the database. So for that, we need to configure two uh, repositories: user credential repository and public key credential user entity repository. So I have created two beans. So Spring Security provides this JDBC implementation for this, and we need these two tables: user entities. So user entity will store the ID, name, display name, and user credential, which will store credential ID, user entity, user ID. So it will be this ID, and then public key, signature account, and these things will be stored. Okay. So these two tables are required. So again, they are provided here. And now with that, I think, yeah. So let me see if there are any existing these credentials created. Okay. Or yeah, let's not do that. Let me start the application. Yeah. So the application has been started. Well, let me go here and I will go to guest profile 9000. Now we are redirected to login. Okay. So here we can click on sign in with passkey. And since I don't have um, any authenticator in my laptop, so that means I don't have any platform authenticator. So I will need to use any roaming authenticators if I want. Let me go. Let me inspect it, and I will show you something. So I just want to show you the this network request. Click on sign in with a passkey. Just cancel it. So we sent one request to okay to browser log. So we sent one request here. If you see, it's a WebAuthn authenticate options, and we got back this response: user verification preferred, timeout RPID. Then this is the challenge, and this challenge. So this is the challenge which the authenticator will sign. So first of all, let me authenticate Alice, and so Spring Security provides one endpoint which is WebAuthn register. So here you can see the list of registrations as well as you can register a new credential. So we have this credential passkey one, so we can create another one here we need. Let me give it some level passkey to click on register. I will just cancel it for now. In the options, we are getting something. So we are getting attestation, none, authentication selection. So resident key required. That means the credentials should be stored in the authenticator. User verification is preferred. That means try to verify the user using uh, biometric ways. This is the challenge which should be signed. Then we have exclude credentials. See, and exclude credentials. So this may be because this is already registered, and we can see that in the database. So I will just and here what is the password? Okay. Now here we have these tables. Let me say select start from user entities. So this is the ID, name Alice, display name Alice, and select start from user credentials. So you can see credential ID is 629FDDX something, and if you go here 629FDX, this is the same one, right? DCY0BL, yeah. So this is excluded credential, so this credential won't be used. Then this is extension public key. So these are the supported algorithms. So this -8, -7, and -257, these are the numbers of some algorithms. So this is predefined. So I will put the link. Then this is the relying party information, localhost, and this is the name demo server. And this is the user for which the credentials should be created. Okay. Now with that, let's register. I will click on register. Now I will need to scan this QR code. So I will use my phone to do that. So, so I go to option to create a passkey. Now I need to turn on the Bluetooth. Now you can see it is connecting, and now it is asking. So it is giving me option like create a passkey to sign into localhost, and Alice username is also visible here. Okay, so you can see that here. Now I will use my fingerprint to authenticate, and see the passkey has been created, and we send back this to this, okay, to the register. So in the payload we send this public key, credential, this authenticator attachment, cross platform, because we use the roaming authenticator, and this client extension, results, options, this ID, this is raw ID. In the response we have attestation object, we have client data JSON. In the transport we have hybrid internal. So these are the things, you can you can explore these more on your own. Okay, so we have that, but now we want to customize it. So let's look at that login as well. So I will log out here from here, okay, and I will click on sign in with passkey. I will again like scan this QR code. Now it is again turning on the Bluetooth. See, now again it is asking me to verify using fingerprint. Okay, and now I am logged in. And again I'm logged in. I can go to WebAuthn and register. So we can see these registrations here. Now with that I will just log out. So we have seen that we can register and we can log in. But now we want to customize it. Let's customize it. Let me go to authentication config. Okay. So I will remove this one, and okay. Yeah, let me remove this. Okay. Yeah. So we have WebAuthn, RPID, RP name, allowed origins. So for WebAuthn, it is slightly different because we need to use JavaScript in our browser uh, to interact with the WebAuthn APIs. So the flow is that whenever someone wants to log in with passkey, we send a request to the server. We get the authentication options. Then we send those authentication options to the authenticator. Authenticator will reply back with some data, and we send that data to the uh, our RP server. And then RP server will uh, return us back with whether authenticated or not. If authenticated, then what is the redirect URI? And then we need to redirect the user to that redirect URI. So that is the flow. And that flow is specified here. If I go here, sorry, not here, the README I have added this one. So here you can see the request and response here. Request the registration options and registering the credential. Then for authentication as well, verifying an authentication assertion. So requesting the verification option and then verifying the credential. So using this, we can do all these things. So let's see how we are doing that. Yeah, so here. So let's go to login.html. So we have implemented that in the login.html. So here I have created one new button called login with passkey. So it has THX and dummy, but when you try to click this, when you try to submit this form, it won't send any request to this dummy endpoint. We will see that the method is post. So I use this mainly because I want the CSRF token. So if you use THX and method, then Timely will automatically create one hidden attribute with name underscore CSRF and value will be CSRF token. We need to use that because we need to send request to the server, and that will be a post request, and in order to send that we need CSRF token. So I will we will see how we are using that. Then this is the ID of the form. Here we have a button. The type is submit, login with passkey. So whenever you click on this button, it will, since its type is submit, so it will try to submit its parent form. That means it will try to submit this form. And now we need to intercept that submit form event. So in order to interact with this WebAuthn APIs, that means to interact with authenticator, I am using one library here, which is called simple WebAuthn. So that is again here, simple WebAuthn. So you can look at this library. Okay. So this has two things. You can like browser, since we are using it in the browser. This has this server counterpart as well, but since we are using Spring, but if we are using some, let's say, if you are creating a server side application using Node.js, that means in JavaScript, then you can use this one if you want. Okay, so we will use that, and then we are injecting our this JavaScript as well from auth-login.js. So in the auth login, okay, we are importing something from API, which we will see. So this API is basically interacting with our server for this authentication of receiving the authentication options and submitting the verification payload. So whenever the like after document is loaded, so this is the ID of the form, and so simple WebAuthn browser. So this that API. So I showed you. So this library registers something in the window. So it registers this simple WebAuthn browser. So there is this one function browser supports WebAuthn. If browser does not support, then we will this we will just we won't display that form in the UI. Otherwise, whenever that form gets submitted, we will prevent default. That means it won't send any request. We will again check whether this public key credential is present in the window or not. That means whether the browser supports this WebAuthn API or not. If not, then we will alert this and then we will return it. Otherwise, first we need to get the CSRF token and which we will get from this sign-in form. So from the form, we will get this uh, value of the field with underscore CSRF. This is name. Okay, that will be CSRF token. If CSRF token is not present, then also we will remove the form. Now we need to send the CSRF token, and Spring Security expects if you are attaching the CSRF token in header, then the header name should be X CSRF token. Its value will be the actual CSRF token. Now in order to we need to get the authentication options from the server. So we are calling this method get authentication options with these headers. So get authentication option, yeah, it is in API. So in the API, we have these two variables. Again, we have seen them. So this is the reference. Get authentication options. So it basically sends a post request to auth options path with the headers and additional header content type application JSON. If everything is successful, then we will just get the JSON out of it and return it back. Once we have the authentication options, then we will sign in using passkey. So what this method will do is this will use this start authentication from this simple WebAuthn library, and we are sending it to this authentication options and the headers. Okay, so now here we are saying it. We are calling start authentication, which internally will call the navigators create method to create a new WebAuthn credential. After that, we are calling verify credential of API. So in the API, we have verify credential. So it takes the verification payload. So this is the payload which authenticator will return back. So we are again sending the post request with these headers and the content type application JSON, and yeah, we are just calling the API. So if in the result we see that it is authenticated and there is a redirect URL, then we will redirect the user to redirect URL. Otherwise, we will just alert that authentication is successful. If it is not authenticated, then authentication failed. If some error, then we will print the error in the console. So that is the flow of authentication. So I have not implemented the registration flow, but you can do that. Now, so that is that. Now let me the api.js. Okay. Okay, let me restart the server and show you how it looks. Okay. Yeah. So this is the form. Not this does not look that great, but this is the form, and we have login with passkey. Let me click here. I will just cancel it. But in the options, you can see we got back this response from the server. So again, we will be able to log in with passkey. And let's try that. Click on login with passkey, and I will scan this QR code. And I will verify using fingerprint, and we are able to log in. You can see we got the options, then we authenticated true, redirect URI, login, logout, and continue like that. We are getting error because we have not specified any endpoint or something. But now in order to test it, since it is an uh, authorization server. So I will test it by actually uh, like redirecting the user to authentic authorization URL flows and Java authorization. So this is the URL where we need to redirect the user. Copied it and let me just log out here. So why is logout not working? Okay, logout is not working. Anyways, let me open it again. No, no, this one. Guest profile. I will paste the URL here. Now we want to log in with passkey. So click on login with passkey. We got back this one. I will scan it and yeah. Okay, so we are logged in, right? So we are redirected. Now let me copy this code from here and I will put the code here and we are getting response code 500 and let me go here to see what is the error. Okay, we can see this error here could not resolve type ID or Spring Framework security WebAuthn and authentication as subtype of Java lang object configured polymorphic type validator. Okay. So we are getting this error and the reason is this. If you see here, when we are creating auth to authorization service, so this is responsible to store this authorization in the database and retrieve it back, things like that. So let me just show you that in action. So these are the tables, and let me select star from auth to authorization and limit one. So here you can see what all we stored: ID, registered client ID, principal name, authorization grant type, authorized scopes, and then attributes. In the attributes, what um, we have some attributes. So for example, how the user logged in. You can see here principal and name alias ID is this one. So how the user logged in, what are their authorities? For example, factor WebAuthn. So we logged in using factor WebAuthn, and this is so these are all the attributes. So and even in authorization code metadata we store in JSON. So what I'm trying to show you is key like many of the things we store them as JSON. So what we do is while storing, we convert the object into JSON representation and then store that. And while reading it from the database, we convert that JSON representation back into the object of that class. And the class is mentioned here. Right? Now, uh, what happens is Spring Security uh, or like you can register modules. So uh, you can register JSON modules. So what JSON module is that we are using one library or Spring Security uses like Jackson, which is very popular library to serialize and deserialize object to and from JSON. So in the Jackson, you can register some modules. So module will be responsible of telling Jackson how to serialize object of particular class into JSON and how to deserialize one JSON to any object of a particular class. Not only that, you can also specify you can also specify that uh, you can also specify the allow list. That means you can specify the for example package name. That means only classes which are present in that package should be allowed to be serialized and deserialized, and then you can specify how they should be serialized and deserialized using modules. Here, when we use JDBC authorization service, so by default, Spring Security includes some modules and some allow list, but it does not include anything related to WebAuthn. So whenever some user is logged in using WebAuthn, so the error is this only. Okay, we were able to serialize it, okay, but whenever we need to read it, say the org Spring Framework, Web Authentication, I will just show you. That should be something like that in the red class. This one. Org Spring Framework Security Web Authentication. So we are trying to deserialize this principal. Principal should be an object of this class, but we have not provided how can we deserialize this JSON into object of this class. So we need to provide that. So let me undo this change here. So this is how we can do that. So this is for one, but if we allow that, then we will get error in this one, and then we will get error in many of the classes related to WebAuthn. So we need to do two things. First of all, we need to allow uh, the WebAuthn to be serialized and deserialized. Second, we need to tell Spring Security how to do that. Sorry, we need to tell Jackson how to do that. So let's see. So we have created a service here. So this is the same. Then we create one type validator. So this is called type validator. So and we are allowing this org Spring Framework security WebAuthn. It's a subtype. So this will work for nested packages as well. Okay, so anything which starts with this one is allowed to be serialized and deserialized. Okay, and then but we need to add the if we use just this validator, then it won't work because this validator uh, doesn't allow everything else which was default in this service. So for that, we can use the security Jackson modules. So this is provided by Spring Security dot get modules, and this can accept two things. First is class loader, which we can provide the class loader of the current class, and then this builder. So now this will do two things. This will return all the security modules which are used by Spring Security, or like Jackson modules which are used by Spring Security, and also it will update this validator to allow all the types defined in these modules. So that means we will have the uh, now this polymorphic type validator will validate everything which is by default validated by Spring Security, as well as this WebAuthn. And security modules has all the modules which are required by Spring Security. So now we are creating a JSON mapper. We are adding these all the security modules, and then we are adding this Jackson module provided by authorization server as well. And then we are adding this WebAuthn Jackson module. So WebAuthn also provide us this WebAuthn Jackson module. And then the validator will be this validator which we created here. So we have created a JSON mapper. But now we need to tell this service to use this JSON mapper while storing something in the database and while reading something from the database as well. So we are doing that. We are creating new JDBC authorization service dot JSON mapper, and here we have parameters mapper. So the row mapper is used to read the row and convert it into Java object. Parameters mapper is used to convert the Java objects into the database row, and we set those in the service and we return that service. So now we are using this service. So hopefully this should work. Let me refresh it. Okay, and so in order to see whether everything works or not, I will again go here, login again, login with passkey, and I will scan the QR code. Okay, I authenticated using fingerprint, and let's copy this authorization code, paste it here, and now we can see it is working. Response code 200. This is access token, and let's try to uh, validate this access token as well. So from here to where is the refresh token? Here, Java, and the name token introspection, and we are getting active true, subject alias audience, and all these things we are getting back. So that means it is working as expected. So at many places, if some website supports WebAuthn, then you may see that whenever you try to provide your username, then you can see autofill where it asks you to log in using web authentication. Or even whenever you try to provide password or anything, even if you try to provide this username for this magic link, you see an option to authenticate with passkey. So let's see how can we implement that. So that is also very easy to implement. Okay. Okay. So in the authenticator, you can provide uh, autofill option. Autofill should be true or false. And simple web authn also support that. So you can use browser autofill. If you provide true, that means it will use autofill. And how it will use that, I will show you just that. So let me undo some of the things. So it will accept autofill, whether it is autofill or the explicit signing in with passkey. So whenever you want to sign in using passkey, we can provide true. Okay, so let me just do this. And yeah, yeah. So what we are doing here is, uh, so we will get the CSRF token headers. Now, since we know that authentication, see this WebAuthn is supported, and so we will just try to directly get the authentication options from the server. We won't wait for the user to click on that login with passkey button. Once we have the options, we can directly sign in using the passkey. But in this case, autofill is true. So it won't log in, it will just, it will be present in the autofill. And whenever someone clicks on that sign, login with passkey button, in this case, we will use the same authentication options, but autofill will be false. So in this case, it will be uh, like direct authentication with passkey. So let me start the server again. Let me go here. Now we don't see anything. Why not? Let me go here. Mm, okay. See, in this case, we see browser does not support WebAuthn autofill. Failed to authenticate with passkey. Browser does not support WebAuthn autofill. It does not support maybe because uh, it does not have the authenticator, right? So because it cannot prompt the user to scan the QR code. So I will close it and I will go to my personal profile. Here, if I try to go to that website, so here I am at this our website. If I click on username here, then it is asking me to log in with Alice, Passkey, Google Password Manager. Because in this case, in my personal, the Passkey is managed by Google Password Manager. It also provided me this option, use Passkey from another device, right? Not only that, even if I try to enter something in password, it gives me an option to log in using Alice. When I but when I click on here, uh, magic link, it doesn't ask me to do anything. And the reason is this: if I go to login.html for autofill, we need to use this one. In the autocomplete, we need to use WebAuthn. So we can use more as well, but WebAuthn should be present. Only then WebAuthn autofill will work for that input box. So you can see for username, I used WebAuthn. For password as well as I use WebAuthn autocomplete along with username and password. But for this one, for magic key, I'm not using any autocomplete, so that's why it is not there. So let's try that. Uh, mm, I have copied it and I will paste it here. See, since it is autocomplete and just by visiting the website, it is giving me an option to log in using passkey. Let me click here and it has logged me in. I will click, I will copy this URL, sorry, the authorization code. I will paste that here. And I'm getting 400. I don't know why, but yeah, let's check why am I getting 400. It says client authentication failed code. Okay, let me check what was the code which I provided. Okay, I did not provide the full code. There was one hyphen as well. I forward that, or I did not copy that. Let me go to, since I'm already logged in. Okay, I'm logged in, or like I have the access token. So that is it. I wanted to discuss in this video. I will provide all the related links in the description and as well as in this README file. I will provide the link to this presentation as well in the README as well as in the description. So with that, thank you everyone. Let's meet in the next one. Bye.